Hello and welcome to this video on PicoDiagnostics. This particular video is going to concentrate on how to carry out a very quick and simple cylinder balance test using our picoscope and the PicoDiagnostics software. Now before we take a look how to set up our software and how to carry out the test itself, we're going to take a quick look at how to connect up our hardware that's required in order to run this test. Therefore, if you take a look at the video in the bottom right hand corner of the screen, you can see that I already have my test lead connected and that this has been connected to battery positive and also to battery ground. And this has been connected to channel A of the picoscope. Now in terms of connecting up our hardware, that's all that's required, a very quick and simple connection to the vehicle battery. So if we move on now and take a look at the software, in order to carry out the test, we simply click on the cylinder balance icon on the left hand side of the screen. This then opens up the cylinder balance test application within PicoDiagnostics, and you can see we are instantly presented with this recently new feature, which is our enhanced setup wizard. Now you can see from page 1 of the wizard that we have a very brief list of instructions that we need to carry out just to ensure that we're going to get a good signal in order for our software to test. So if we work through all the stages together, you can see that stage 1 is telling us to connect channel A of the picoscope to the electrical system. Now I've already done this direct to the vehicle battery. However, you may work on an application where either the battery is not accessible or where the battery is positioned, like for example in the rear of the vehicle, that your signal strength can't be well obtained. Therefore what you can do is you can go directly onto the back of the alternator. Now please be careful with going on the back of the alternator, because as we know the alternator is usually driven off an auxiliary belt, therefore there is reciprocating and moving parts there. But also on most modern applications now, where engines are being made more compact to fit into smaller engine bays, the alternator can be positioned near quite hot components, such as the exhaust. So if we are going to use the alternator as an option, just be careful that we're not going to cause any danger to ourselves, or that our equipment's not going to be positioned where it could cause some problems later on in the test. Now if we take a look at stage 2, you can see that it's asking me now to switch on my headlights, and stage 3 is asking me to start the engine. So I'm just going to go ahead now, I'm going to turn on my headlights. And I'm going to start the engine. Now if we take a look at stage 4, we can see that the software is doing a very quick voltage check for us, and again that's streaming live. You can see that it's giving me around 13.6 to 13.8 volts. This is slightly higher than our normal output engine idle, and that's because we've already got the headlights on. So what we've tried to do there is we've tried to put a slight electrical load on the vehicle just to give us a good signal output. So what we're going to do now is we're going to click on next. Now the next page of the wizard, this is where the software needs to know how many cylinders there are on the application in which we're going to test. Now in this particular application it is a 4-cylinder engine, and you can see that 4 was already selected for me by the software as the default option. So all I need to do now is simply click on the next button so we can move on in the wizard. Now the final part of the wizard is our signal strength meter. Now you can see that I've got a good RPM output there of around 850 RPM, which on this particular application is perfect, but you can see by the meter itself that I've got a very good strong signal. That's approximately 90 to 95%, although it is slightly fluctuating. Now when you come to carry out the test, you may see that your signal could be very weak, and it could be either orange or it could even be a red, very poor signal. That could be on a number of factors of where the battery is positioned or where your connection is, but you can improve this by simply adding on extra ancillaries, i.e. increasing the electrical load on the engine. Now to do this you can simply turn on ancillaries such as heated windscreen, interior heater, front or rear fog lights, and also taking up our dip beam to main beam. Just enough ancillaries just to get our signal strength up. As you can see mine's pretty good. I'm going to click finish just to complete the wizard and accept all the information I've put in. So all we need to do now in order to carry out and run the test, we simply click on the start button in the bottom left hand corner of the screen. Now you can see our software and scope are talking to each other, getting our data, and you can see there we are. We are presented on screen with a live streaming output of what our cylinders are each contributing towards that engine. Now note that I've just said this as live. In previous versions this has been recorded and presented on the screen. However, now a recent enhancement to the software is that we can run this test live. And this is very, very useful, because if a cylinder was to drop out or was to misfire whilst we're running a test, we'd see this actually on the screen. Now, to prove this, what I'm going to do is I'm going to disconnect injector number 3 of the engine, and what we'd hope to see is that one of our cylinders is going to drop out, and then when I connect it back up, hopefully we're going to see that come back up again. So I'm going to go ahead and do that now. You can hear the engine's not very happy. You can see that our signal on cylinder C, or our output shall we say, has dropped down to 10%. Now the reason it's given a 10% reading, not 0, is if you think of that cylinder now, it's now acting like an air pump, so we do have compression still taking place, which is going to give us a resistance on our piston and conrod, and this will be seen by the alternator. Now if I plug the injector back in, what we should see is a nice increase back up to around 98, maybe 100%. There we go, you see we're back up effectively near enough 100%. What's also very useful is if you look at the bottom of the screen, just under each bar, you can see that there is a counter that's increasing all the time. This is our sample count, and you can see that we're already approaching 2,700 samples. We've just gone over that. But if you take a look at cylinder C, you'll see that this has 800 counted misfires. If you look at cylinders A, B and D, you can see that these are very low, around 100. And the reason for that is every time a misfire occurs, or the software detects a misfire, it registers this as a count. So cylinder C has a very high misfire count compared to the number of samples taken, and again this was the cylinder in which we dropped out. You can also see that we have our RPM meter still at the bottom of the screen, and this is recording live, and our signal strength meter is still there as well. And this is very important, because if our signal was to drop out and the results were to alter on the screen, we'd know straight away it wasn't actually the engine, it was our signal, and then we could rectify that again by changing the electrical load on the engine. Now I hope this video has been of some assistance to you and helps you when you come to carry out a cylinder balance test, and I thank you for your time and thank you for watching this video. Thank you very much.